All right, hey everybody. I'm Arash Amini. This is the truth about global warming. Now, my interest in global warming is very technical in nature. I'm concerned about food safety and food security at the global level. There's a big shortage of food coming, estimated between 2028, 2035, something like that, due to solar activity. And I'm going to explain why we should all be worried about global warming and acknowledge that, climate change, and acknowledge that the global weather patterns are shifting, but we got to understand why to end this debate and move towards action. So, if you want to protect your family's food safety and food security, you got to get a StackFarm. It's the simplest way to grow indoors and provide super nutritional food for your family. There are DIY kits and DIY training at stack.farm/DIY. So, all right. This chart explains everything you got to know about global warming. It's the ranking of greenhouse gases by their contribution to the greenhouse gas effect. And I'll get into this later. So we have water, H2O2, contributes 36 to 72% of the greenhouse effect, up to almost 3/4 of all global warming is caused by water vapor. This is really, really important to understand because that's the key that's going to drive our weather for the next 50 years, it seems like. At least 25 years. And we're getting into a shitstorm right now. CO2, this little bugger gets 99% of the attention because we are cranking it out at record levels. And there's no denying that. We're pumping a ton of carbon into the atmosphere. Now, the key thing to understand here is that it only contributes 9 to 26% of the total global warming effect on Earth. And then the rest is methane and ozone. We don't have to worry about these. There's a ban on, these are much smaller concerns. Let me put it that way. The reason we got to worry about H2O2 is because the sun is entering into a low energy state right now. As like anything else, like anything else in the solar system, it comes in cycles, and it's right now virtually quiet, and it's entering multiple cycles of the sun are combining to create what people call the grand solar minima. And during this phase, the sun is not creating, its magnetic fields are, I think, have shifted, something like that. And as they shift, they're stable, and you don't have a lot of sunspot activity. Its magnetic field is decreasing. It's a lot of physics to keep track of here, and I don't remember exactly what the cause is. The poles of the sun's magnetic field are drifting, and they move from north-south to south-north. While they're moving, that friction, you can imagine two magnets moving and switching places. As they're moving, they're creating all sorts of complex interactions of their magnetic fields. You can think of it as like friction, because what's really happening inside the sun is you got this plasma, this supercharged plasma, and it's under the force of gravity. Let's break down some of that. We'll get into that in 1 second. The nail in the coffin here is the parts per million, the amount of this chemical in the atmosphere. CO2 has only 400 parts per million. So if I sampled a million molecules in the atmosphere, only 400 would be carbon dioxide. 50,000 parts per million of water. So we're talking massive scales. And sure, CO2 is probably a stronger methane, and methane even more so is a stronger greenhouse gas, but its sheer volume dominates the effects of the other two. Okay? So what's going on in the sun right now? The sun is an insanely complicated physics problem, and it can only be estimated and measured. And it's only really been measured since the 1970s by satellites. So our magnetic data of the sun, magnetic recordings, are rather old. But the interesting thing is sunspot recordings have been occurring for thousands of years. And it turns out, and I'm going to explain real quickly, why that matters, why sunspot activity correlates directly, is a direct measurement of magnetic activity. And so that you have the sun, and for the example of a physics problem, we can simplify it to a sphere, and it's spinning on some axis, right? And to simplify this problem, you can think of it as a metal ball spinning on string in some direction. And this metal ball is charged with, let's just call it Q. The total amount of charge on the sphere is some value Q. Now in reality, if we wanted to make any sort of calculation from this, we'd actually have to, it couldn't be a metal ball, it's actually a plasma spheroid, because plasma, as it rotates and is charged, behaves differently than a metal ball. But if you're looking at it from the outside, let's say, it just has some total amount of electric charge that we're calling Q, and that charge moving and constantly accelerating towards the center. If I am holding your hand, that's not a good way to describe it. It gets really complicated really fast because plasma behaves like a liquid. Plasma is gas, electrified gas. It's gas with a ton of electrons, and it has this thing that it can be anytime you supercharge almost any material, it'll melt. And the material that has a lot of electrons in it, like metal, like helium, I don't know shit about solar physics here, but I'm trying to describe it in a succinct way. There's all these interactions going on. Let's forget about the electric field, because a spinning electric field is really all you need to know. It creates a magnetic field. So the sun has this magnetic field, just like the Earth. And these the magnetic field of the sun aligns with its pole, created by a separation of charges or some other complex phenomena. But just like any other planet in the solar system, you have these spinning things. And so this is like a static state. So you can think of this as a magnet whose these lines, if you were to put a little charged particle, it would, how do I say this? For magnetism is really hard to explain without just pure math. It makes no fucking sense, okay? Remember that rap song? It was like guys with painted faces are like, how do magnets work? It's a miracle. Like, it actually is. Without understanding the math, there's no good way to describe what the fuck is a magnetic field. And it drives me crazy as a physicist, trained physics major with a poet heart. It's like, it's very trippy. And so, for all intents and purposes, we can all imagine a magnet that we buy from the store, and we put two of the positive sides together, they repel. We put negative and positive, they attract each other. And it's because, or it's modeled or measured by what we call magnetic field lines. And magnetic field lines move from positive to negative. And that model lets us, it describes a lot of other interesting phenomena, so it's pretty solid. So this is switching. This is flipping. Now the sun isn't flipping, but the charged plasma, the magnetic field inside, is flipping. And you can imagine, how do you flip a magnet that's spinning at God knows how fast, that's God knows how large? It cannot happen easily. And so it's this slow migration where the magnetic pole of the positive starts drifting, and some other random causing the bottom to drift in some other random process. And slowly they take this meandering path and they flip. Remember, it's almost a liquid inside. It's a supercharged plasma. It's a super dense, super hot gas, effectively. And you could think of it as like lava, almost like lava that's moving really fast. So it's more liquidy. It's not that oozing lava. It's more of a watery lava, but it's charged. And the reason that I keep drilling that is because when charged particles move, they create magnetic fields. And so this whole thing is fucking going on. No one understands it. And the key is when these poles kind of rub together, because now they're causing magnetic fields like this that are interacting with that, and it's this whole fucking crazy mess. You get these knots in the magnetic field where the magnetic fields wrap around each other and cause the plasma to cool. I'm not going to get into why, because I don't even fucking understand why, but those magnetic knots that cool the plasma in the sun are what we call sunspots, because they're visibly, or from all our imaging devices, they look like dark spots on the sun. Okay? So if you know any math or physics, you might be screaming at me, but you get my drift here. Okay? The poles are moving, and as they move, they cause friction, and as they cause friction, they create sunspots. Magnetic friction. That's a made-up phrase. So, I think our sun's poles just flipped recently. And we have let's see, this is like 1970. This is like 0. This is like, I think, negative. Not negative. Okay, something like that. And this is like 20. Something like that. Okay, so historians have been tracking the sunspots on the sun all the way to like 2000 BC, to the ancient Chinese astronomers. And the more sunspots, the more friction, if you will, the more magnetic activity. The more magnetic activity, the more the larger the magnetic field of the sun becomes. That might be jumping to assumptions, but magnetic activity, sunspots on the sun, correlate to the strength of the solar field. People have just discovered that. I don't know why, but that's a discovery, and it could be mapped to an equation. So by measuring sunspots, you get the relative strength of the sun's magnetic field, based on some of that bullshit I was trying to describe earlier. And, you get these like crazy clusters, and it's not exactly the best way to draw it. Let's say this is zero magnetic activity, right? And you get these like crazy, no, that's not the right way to draw it either. And you end up with this, something like this, to this effect. Some crazy wave pattern that matches all the magnetic recordings of all time. Let me step back here. So you had sunspots measured up, from now all the way back 2,000 years. 1970, so this whole area, we got data showing sunspots. 1970 until like today, we have satellites out there that measure the magnetic field of the solar system, of the sun. And then we have like today. Okay, so this is all known data. This amazing physicist out of, oh man, I can never remember her name or her country. I feel like an idiot. But she's brilliant. She took all the magnetic recordings and fed it into a computer that used this, effectively brute forced an equation, or matched an equation to all these data points. And when you map that equation onto an overlay on the magnetic field observations, the sunspot observations, you get like almost perfect match. And then, okay, you're like up to today. And then you wonder, so let's talk about that. When an equation matches all previous known data, it's a very good indicator that its predictions are going to be accurate. Think about it. Think about it in any case. If you were right every day, and you're a weatherman or woman, and you were right on forecasting the weather, people would start believing in your predictions. In this situation, if you could ask me, it's a hard thing to describe outside of the philosophy of science, but in the philosophy of science, when a model predicts all previous data and provides insights into previously unexplainable data, and like simplifies our understanding, and as well as predicts something new that we can measure, right or wrong, falsifiable, it's usually a front runner for a better model in science. So we have the anthropomorphic global warming, is that right? Movement that believes humans are causing the increase in temperature, but I don't believe that's the case. Not only is H2O far more prevalent and a larger impact on our Earth's climate, we also have to figure in the magnetic field strength of the sun. And so this equation that she maps out goes to where we are now and into 2025 and beyond. And it shows, this was several years ago, she predicted that we'd be entering a solar grand minima as the cycles of the sun, for whatever fucking reason, compact and collapse, and we get a trough, a canyon, a mega downtrend in solar activity. That means okay? So I wish I could get into this, but it's just fucking math. And it's more math in one presentation of hers than all of the fucking models of anthropomorphic global warming have provided. It's really solid. The key takeaway is that she takes all the sunspot activity from the sun, puts it in a computer, gets this chart. It lines up perfectly with all past sunspots, and it predicts in a few years when she first released it, it predicted a grand solar minima, which we're now seeing right now. Okay, oof, man. Now we got all that base material out of the way. This is why it matters, okay? That's the sun, all right? And planet 1, 2, us. What is it? 1, 2, 3, 4, 5, 6, 7, 8. Sorry, Pluto, right? This is, man, I've been blanking on what was the furthest planet out from the solar system? Uranus? Okay, that's just the edge, let's say. Right, we all know this. Sun, planet, so on and so forth. What we don't talk about enough is, and let's zoom out. Okay, so now the sun is this big, and the whole solar system that's the 9th planet, and we're right here, let's say. There is a gigantic magnetic field covering or encircling or encompassing our entire solar system. It's called the heliosphere. So we're hurtling through space right now. We're spinning and we're spinning around, and then this thing is moving. The solar system itself is moving through space. So if I made it, we're going around some other, probably the galactic center, whatever the giant black hole, the center of our Milky Way galaxy is. We're all spinning around each other, right? This heliosphere, this magnetic field of the sun is so massive that it encompasses the entire solar system. I don't actually know if this is the scale, but I do know the heliosphere lands far outside the edge of the solar system. And it is scientifically or allegorically defines the edge of our solar system. Why? Because it is a giant magnetic bubble that encompasses us and repels high energy particles from entering, highly charged, extremely fast moving particles from entering our solar system. This heliosphere is weakening right now, objectively. You can't deny, you can look up at the sun with a telescope, with the right equipment, and you see almost no solar activity, no sunspots. As this thing diminishes, and it gets weaker, those particles are going to start coming through more. And you might be worried, what does that mean for us? Well, the Earth has several safety features. So let's talk about the Earth now. Right? It has a tiny sheet of atmosphere. It has its own magnetic field. But it's nothing compared to the magnetic field of the sun. And that atmosphere is made up predominantly, that's not the right figure, it's predominantly made up by water vapor. Over 90% of that atmosphere is water vapor. Is that right? Someone check that. Large majority of the gases in the atmosphere are water vapor. That water vapor we saw earlier contributes the most by far to the global warming effect. This is broken down to just gaseous water. That's maybe about 50% of this 72 to clouds. I think it's about 25%. Those high energy charged particles, from what I can gather, what other people are saying, what other scientists and physicists are saying, it's going to decrease our cloud coverage, which is more important than carbon dioxide. It's going to affect the cloud formation because clouds have to form around like a nucleus, they start at a couple of droplets and then they grow and grow and grow. If that couple droplets gets slammed by a high energy particle flying in through space while we're actually flying in headfirst into it, right? We're going like this, and these things are just, they might be sitting there, but not sitting there, but they're also moving. So the impact is tremendous. And water is highly magnetic. So you get this increased agitation, and it's going to decrease, physicists are believing it's going to decrease our cloud cover, which is our predominant greenhouse effect in gas, and will actually lower our global temperature. The scientists that discovered that waveform of the sun's magnetic field predicts 2028 to 2035 or something in that range we'll see food shortages because of this series of events that is completely beyond our control. It's a very complex, multiple complex systems. And let's really be thankful here. If you see all this shit and you don't believe God perfectly crafted everything to live on this planet under our little skin wrapping paper of a climate, of an atmosphere, hurtling through space, shielded by our magnetic field, shielded by a larger magnetic field, constantly defending us from ripping apart our cloud coverage, which would effectively take the blanket off the Earth and let all the heat out. I mean, it's incredible. So, the reason I'm so passionate about indoor farming is because it's a simple and straightforward solution to a global coming crisis. These systems are not expensive, and you know what? Yeah. We're selling the kits if you want to buy the kit. But if you want to design your own farm, you got to go over to stack.farm/DIY, sign up for that free DIY training course material membership, and you'll get access into how to grow your own food. Winter is fucking coming. There's no way around it. And if you don't believe it, you probably already know about it. Look at #NoPlant19. This is going to be an increasing event. Global agricultural disruption. Okay? So I don't want to freak anybody out. We're going to get through it. We're the smartest people on the planet that are highly motivated, working on the solutions. But you got to get into your own home for it to matter to your family. So build your own StackFarm. There's no other way around telling you guys that. So I've built this whole fucking project, this whole company, to help you avoid this by getting one of these. We'll start expanding the capabilities, but that's not going to happen without your support. We need members to back this company in the membership training area to support the R&D that can then go forward and roll into manufacturing the right equipment at the lowest possible cost. So I want to keep the costs down and create a membership model because you're continuously getting value from the community with recipes and knowledge and updates and hacks and tips and so on. But the equipment, I believe, should be as cheap as humanly possible. So here we are. All right? And there's a lot of physics. I know I've messed up at least 2 or 3 things, but I hope the big picture is clear. This is the truth about global warming.